In section 7.7, you're going to be using two ways to figure out if elements make a covalent or ionic bond. In the first method, you're going to use your periodic table. Just a refresher, an ionic bond is a bond between a metal and a nonmetal. Covalent bond is a bond between a nonmetal and a nonmetal. The first thing is you're going to take your periodic table and you're going to look at where the metals and the nonmetals are. Remember that you can look at the ladder, and anything to the left is going to be a metal except for hydrogen, and everything to the right of the ladder are going to be nonmetals. So for example, this first row here, NO2, N, nitrogen is right here, O, oxygen is right there. They're both on the nonmetal side. So since we have two nonmetals, that's going to make a covalent bond. If we look at the second compound, sodium Na is right there. Chlorine is over here. So we have a metal and a nonmetal. And since we have a metal and a nonmetal, that's going to be an ionic bond. And then let's do another example. CO2, C is carbon, it's over here. Oxygen, we already looked at, it's right there. So we have two nonmetals. And whenever we have two nonmetals, or two or more nonmetals, that makes a covalent bond. Figure out where the metals are, where the nonmetals are, and whichever combination you have, you're going to look at this over here to figure out if it's an ionic or covalent bond. For 7.2, you're going to be using math to try to figure out if it's an ionic or covalent bond, and then pay attention. Now here, there's two different categories for a covalent bond. There's a polar and a nonpolar. So depending on what you get for the difference in electronegativity, that's going to determine the type of bond you have. So to do the math piece of this portion, there's a video that's linked over here. So you're going to go ahead and watch that video. It shows you exactly how to do the math piece for this. And it shows you how to figure out what kind of bond type it is. So you're going to do a little math, figure out which type of bond it is, what range it falls into, and you're going to write that down here for the bond type. What I'm going to show you is how to do this step right here, how to draw the dipole moment. So the dipole moment is this. I'm going to show you how to draw that. So what you're going to be doing for this is first, in that bond that you're looking at, you're going to try to figure out which atom is more electronegative. You're going to use your periodic table. You're going to again figure out where the elements you're looking at are located. So for example, sulfur is right here. Cesium is over here, and then you have to remember the trend for electronegativity, which says electronegativity is increasing this way towards fluorine, and it's increasing this way towards fluorine. Sulfur compared to cesium is going to be more electronegative. So since sulfur is more electronegative, the arrow or the dipole moment is going to be pointing towards sulfur. So that dipole moment is always going to be pointing towards the more electronegative atom. If we look at chlorine and bromine, chlorine is further up. It's going to be more electronegative than bromine. So then this dipole is going to be pointing towards the more electronegative atom, chlorine. So that's what you're going to be doing for the dipole moment. You're going to look at your periodic table, look at the trends, and figure out which one is going to be more electronegative. Whichever one is more electronegative is the one that's going to have that arrow or that dipole moment pointing towards it. And then one other thing I forgot to mention is, to figure out the difference in electronegativity, you're going to be needing this chart. This chart I put on Canvas for you. You should have it in your paper journal, but in case you don't, it's on Canvas. That's what you're going to be using to calculate those differences in electronegativities. So what I'm going to be showing next are going to be the keys for the key for 7.7. So here's the key for part 1 of 7.7. So go ahead and check your work using this. And then here's the key to part 2 of 7.7. So go ahead, use this to check your work. And just one thing, notice that for the I bond, so iodine bond, there is no arrow drawn there, and that's because if you look at the difference in electronegativity, that ends up being 0, which means that attraction to the electrons is going to be shared equally, so it's going to kind of cancel itself out. So you're not going to see a dipole moment.